Hello, and welcome to How to Make Lewis dot structures with covalent molecules. But before we begin, what are Lewis dot structures? Well, they were named by Gilbert N. Lewis, and he wanted to show the bonds between atoms, to show where lone pairs are located within molecules, and to give an idea of what the shape of a covalent bond looks like. A covalent bond, for those of you who do not know, is created when two or more nonmetals share their valence electrons to complete their outermost shell. For example, here we have H2O, which would look something like this as a covalent molecule. Pretty cool, huh? Now these are the steps to building these diagrams. Now for today, we will be using one special molecule, CO2. Now the first step to building these molecules is to find the central atom and place in the center of the diagram. It'll be the one with the most open spaces. Now we're going to go with our little friend carbon. It's going to have 4 open spaces. Its electron diagram looks like that, right there. Next, you're going to draw the other atoms surrounding it to make their valence electron dot diagram. So C, we'll redraw that carbon, put the oxygen on either side, right there. Oxygen on the other side also. Now, for the next step, we're going to find the spots between where bonds can be placed. And you pay attention to rule of octet, which is really important. Octet being to fill the 8 spaces. Most valence electron shells will hold up to 8 valence electrons in total. So we'll have carbon right there, oxygen, one oxygen on both sides, because in nature we like to keep things balanced. We'll have the two, what we call lone pairs, which are the 2 dots above the oxygen, one and below one the other. Now you're going to see that we're moving them around so we can start filling up those shells. The one carbon and the one below carbon will go to their respective spots as the line is pointing. And we'll have 2 dots right there, which will signify a bond. And we have another one from the other electrons that are moved on both sides. So we'll have a double bond on carbon right there, and a double there. So to finalize our answer, yes, the 2 electrons are right there, going on top and bottom. But note, there will always be exceptions to these rules, which we'll go over probably another time. But back to what I was saying, to finalize this, the most correct version of this Lewis dot diagram would be an oxygen with a double bond, carbon, with another double bond to the other oxygen, and the lone pairs are which are the 2 dots above and below each one. And that is our final answer for that one. Carbon, CO2. So let's look at our next example. HCN, or hydrogen cyanide. So we're going to find our central atom, which in this case will be carbon. It's going to have its 4 spaces as we draw our valence dot diagrams. Let's just go ahead and draw the other ones as well. So hydrogen will have 1 valence electron, and nitrogen will have 5 valence electrons. 1, 2 on the top, and 1 for each of the other spaces right there. So carbon, as you said, will be our central atom. As we can see, it's because it's going to have 4 spaces as counted right there. 1, 2, 3, 4. So carbon in the center. And we'll have hydrogen on the left side just to keep things, a little orderly. So we're going to have that 1 electron be shared with one of carbon's electrons as shown right there. But carbon has 3 other electrons to go. So let's put them on the right side. 1, 2, and 3. And we'll have the nitrogen on that side right there. Yeah, there we go. Now nitrogen, because it's going to have also, look at that, 3 electrons. 1, 2, 3. It looks like they'll fit perfectly with the carbon, so the 3 will go right there to form, and interestingly enough, a triple bond. And the lone pair, which would be the top guys on top of nitrogen, will go off to the side. So our answer will be hydrogen with a single bond to carbon, And carbon will have a triple bond, signified by the 3 lines, to nitrogen, and nitrogen will have 2 lone pairs off to the side. Now for our next example, turns out you can also make these models for ions, which is shown by this sulfite ion, SO3 minus 2. So let's take our kind of inventory here, and we'll just put that sulfur in the center, as you can see, because it's going to have the most open spots, and we'll surround it by the 3 oxygens right there. Now, sulfur, so oxygen, it's going to have those valence electrons on the outside. Oxygen has a total of 6, and naturally, so we're drawing those 6 out there. 1, 2, 3, 4, 5, 6. Yeah. And then sulfur right there will also have its 6 valence electrons. 6 valence electrons. Now, but because this is an ion, it's going to have the 2 extra right there. So let's just go ahead and move them up there just to keep things a little bit more interesting. So our final answer for that one will be oxygen, which that one oxygen will share a double bond with the sulfur, and then the other oxygens will just have one bond with the sulfur to create the Lewis dot diagram for the sulfite ion. So I'm Mark Camarena, and I hope you've enjoyed this video, and thank you for watching.